Hi, everyone. Welcome to Waste 360's Nothing Wasted podcast. On every episode, we invite the most interesting people in waste, recycling, and organics to sit down with us and chat candidly about their thoughts, their work, this unique industry, and so much more. So thanks for listening and enjoy this episode. Hi, everyone. We hope you had a wonderful holiday, and we have a great podcast for you. This is the new modern MRF, shaping today's MRFs in the wake of COVID-19. And this is a great discussion about MRFs, materials, contamination, what you need to consider, what the obstacles have been and were in 2020. So go ahead, give a listen. We hope you enjoy it, and we hope you listen to more. Thank you.
Good afternoon. My name is Anne Germain, and I am the COO and Senior Vice President of Regulatory Affairs for the National Waste and Recycling Association. I'd like to introduce you to today's speakers. We have Brent Hildebrand. He's the Vice President of Recycling for GFL Environmental. We also have Nat Agosi. He's President of RRT Design and Construction. And we have Chris Hahn, CEO of Machinix Technologies. You may read their individual bios on this session's page. So let's start off. I want to start off just talking about regionalization and MRF size. And so let's dive right into that. So Brent, I'd like to start with you. So over the past few years, we've seen MRFs getting bigger and more regionalized, which leads me to the question, how much bigger are we going to get? Or, have we reached the max size?
Yeah, that's a great question. The name of the game these days is to safely and just highlight safely produce or process as much material and as efficient as possible while still making the right quality based on what's going on across the globe with the quality issues. So the sweet spot on the regionalization side of things, I think is around 35 to 40 tons per hour. As far as how big is the right size, you can go bigger, but at that point, I think you need to look at maybe running two smaller systems together, and I'm sure Chris can talk more about that. But I also think there's a lot more to that question as well. You have different items such as geography that come into play, right? When it comes to the regionalization approach, there's some geographies that just can't support a single stream system because they may not have the labor force or they don't have the volume, so they do have to deliver to a bigger regional facility. Labor force, that comes to mind as well. It's getting harder and harder to find people, right? I think that's a common issue in the industry. So will a marketplace support having the labor available? And then efficiencies, that's a big one too, right? How much more efficient can these facilities get? And this is a great panel to talk more about that. If we can get more efficient, then you could maybe go a little smaller too. So that's kind of my take on it. A good operator can make a smaller system work well if the geography can support the system. But that whole hub and spoke and regionalization is becoming a pretty hot topic, and materials getting delivered from those smaller communities that can't support those systems.
Thanks, Brent. So that leads me right to the other end of the spectrum. So on the other end of the scale, Nat, I'd like to ask you, since you design MRFs, how small is too small to remain viable or even competitive?
Well, that certainly is a good question, since the majority of all the MRFs in the United States and throughout North America are small by a definition of 30 to 35 ton an hour MRF. That's a very small fraction. MRFs, most are substantially smaller. So that sort of leads me to my comment that when we look at a smaller MRF, really their definition, the people who have the smaller MRFs define their MRF quite differently. They're defining their MRF in the context of providing service to the community and their residents. They're defining their MRFs as providing leverage in the marketplace, sometimes against the private sector. obviously I'm referring to the municipal perspective. And also they define it as a tuck-in or something that's integrated with their other operations. And they don't really understand necessarily what the costs are. It's a loss leader perhaps, but it's something strategic in their brand or in their message on the private sector side. And on the municipal side, it's for providing services to the community. So within the definition of a MRF, some of these smaller MRFs is kind of odd. You might see a smaller MRF that doesn't have a baler in it. So how does that make it a MRF? Just how they define their facilities, right? There's a lot of transload facilities that are simply taking material and transferring out. So on the smaller facilities, they might process the fiber side, but transfer out the containers on a dual stream type program. Dual stream certainly is alive and well in many communities. And with regard to dual stream, smaller MRFs can be quite interesting because you can run one line, one portion of the system in the morning, the other portion in the afternoon. We've seen some of these smaller MRFs actually have a high capacity, maybe 10, 15, 20 tons an hour, but they only run maybe 1 or 2 shifts a week. So there's a lot of variation here, and I guess the message really is seeing the definition of a MRF, and therefore when we talk about smaller MRFs, it really comes down to how they define what a MRF is.
Thanks, Nat. So Chris, I want to continue the discussion on the smaller MRFs because there are, as Nat said, a lot of existing smaller MRFs out there, especially some of the earlier MRFs that were built. So is there a possibility for those MRFs to pivot into something else? So, one of the things I think about are small grocery stores that are being outcompeted by some of the larger grocery stores, pivoting to offer different types of services like gourmet or high-end offerings, or exactly the opposite, maybe low cost, no frills. Is there something a MRF could do to pivot to remain in business?
Yeah, so pardon me. Nat hit on a good bit of the possibilities of running some of these smaller MRFs. We'll call them the boutique MRFs now, as the way you put it. But these smaller MRFs may run as a dual stream. You have the possibility. We've also seen trending towards, like Nat had mentioned, running a shift of fiber, being able to process with the sorting head count that you would have on that, and then potentially run the containers at a separate time. So remaining within the single stream and trying to improve on efficiencies and qualities is always something that the smaller MRFs could do. But there's also trending towards, boutique materials. I'm sure we'll hit on that throughout our discussions, but is it possible that we could take a MRF that's smaller and a little less competitive in the marketplace could trend towards bringing in mixed grades of containers and mining for polypropylene for the recycling partnership? Is there the possibility that you could do more fiber quality improvement? I know there's plants that are being designed to do just that, to take in MRF fibers and try and upgrade the quality. Flexible packaging has become a lot of talk in the marketplace. So within the existing streams that currently come out of MRFs, there certainly could be a possibility to take some of these streams and try and further segment them within some of the smaller facilities.
Well, I'm just gonna add that with regard to the smaller MRFs versus the larger MRFs, if you look at the residue that comes out of those two facilities, it's like night and day, right? So the smaller MRFs will have substantially lower residues, be very thoroughly sorted and picked through. And to your point, Ann, about a boutique, that's kind of like what you would expect in a boutique shop, things to be a little bit more precise and accurate. The larger facilities have a different perspective on how they're approaching the residue stream, generally more geared towards the profitability. And in reality, if you go back to the smaller MRFs and you look at how much they reduce their residue, that might not have been a cost-effective decision on their part, but it's more the optics. Just like a boutique shop, a lot of things in a boutique store have really no economic justification behind it, perhaps. Sorry, Ann, but it would be more interesting to a consumer that goes in there and is really looking for that special item.
Yeah, I'll just add
Oh.
real quick. I mean, both Nat and Chris have talked about it, but technology does come into play, and I think we'll talk more about that later too. But you can make these smaller MRFs a little more technically advanced. Optical, robots, artificial intelligence, that can make them a little more viable in different marketplaces.
Well, so let's talk about technology. So Brent, let's start with you. So obviously MRFs are a quintessential Rube Goldberg machine. We've seen numerous advancements over the years, but like Rube Goldberg, they are vulnerable in that, often when there's like one thing that causes a problem, the entire system shuts down. Is there anything that's being done to kind of address that, to allow a little bit more flexibility, to be able to take something out of play and keep everything else operating so you don't lose productivity?
Well, so I think everybody on the panel would agree that there's no substitute for a great maintenance program for these facilities. That's really where the rubber meets the road. But as far as technology and different things manufacturers are doing, there's things happening that are helping with eliminating some of that downtime that you talk about. Manufacturers are getting really good at designing systems that are more easily maintained. When you design a system, at least that's what I look for, is what can we do to make the maintenance easier and quicker to get done so we can get back up and running. Redundancies, there's designs today, it seems like, are becoming the norm with adding, two balers with redundancy, where one baler goes out, you can switch all materials to the other baler. That's helping tremendously. And then again, that technology word, right? You have things happening with artificial intelligence and robotics. We're not there yet on all fronts, but I can see where artificial intelligence might actually start monitoring things like bearing temperatures and let us know these bearings are about to go out. Or, I do have in the system running behind me here in Detroit, we have some artificial intelligence where I have it set to alert me with certain things it might see. So that's also helping on that front. But just to kind of bring it back, the maintenance program, there's no substitute for a good maintenance program on these systems.
Great. And that, we're talking about other technology options. One of the things that we used to see MRFs bragging about is having an optical sorter. Now it's not uncommon to see MRFs with perhaps even a half dozen optical sorters. So have we reached peak optical sorters? And if not, are there other advances that we can expect that will make them even more compelling to use in a MRF?
So the reason why we see optical sorters is because of their efficiency in recovering recyclables by distinguishing them from other items like contamination or other kinds of recyclables, and their reliability in doing so, and their, using Brent's comment about maintenance, they're relatively low maintenance activities. And low maintenance in the context that they're replacing people, and people can be high maintenance. There's cost associated with recruiting them, training, keeping them safe, having them report to work, and providing proper amenities for people. And the degree of complexity in terms of the evolving ton, reused waste, in terms of all the different commodities, has made that very difficult to maintain a sustainable operation with all those changes, as well as meeting all the market grades that was mentioned earlier by Chris and Brent. So if we have difficulty of finding people and the material composition keeps changing, in particular not only the percentages between the different types of commodities, but also the number of units or number of pieces, like OCC, more of that. And minimum wage, for example, I'm here in New York, and we're shooting for $15 an hour. What the minimum wage is going to be, and the federal level is 7.25, and a good part of the country is still at 7.25. and generally way south of 15. So, between the wage rates and these factors, I think that the standard of having one optical sorter, we went past that a long time ago. The idea of having 3 to 6, we're passing that right now, and I think you'll expect to see substantially more than that at the facility as time goes on. And there's good reason for that, as I mentioned.
Okay, so Chris, let's talk a little bit about robots. So even though robots have been talked about the last few years, most of the facilities that I'm reading about, perhaps they're installing one, they're installing two. We're not hearing about what Nat was just saying about optical sorters, half dozen, perhaps even more. So can you talk a little bit about what the current limitations are with robots and AI, and also perhaps speculate a little bit about how they're going to be overcome and what we can expect about robots in the future?
Sure. Well, good question. Robots, they're beyond infancy at this point. I think everybody has come to respect and understand the position that robots serve currently in our market. It's not unlike, we started the question talking in regards to some optics, and, optics were accepted early on. They were in their infancy in a MRF. They grew, and now we're talking, 4, 5, 6, 7 optics in a facility. And I think that's ultimately what you'll see with robotics. Although they're not in their infancy, I also wouldn't suggest that robots are in full adulthood at this point yet either. So, as adolescents, they're doing a great job where we place them as manufacturers. Limitations kind of become the introduction of the material to the machine itself to be able to pick it. It's not unlike an optic. An optic works in its most efficient form when you spread the material out, and to perform that task, you have to speed up belts to a significant belt speed where a human sorter is actually not going to be able to pick off of it, and you're relying on that automation. A robot, by the same accord, cannot necessarily keep up with the speed of those belts. So you're limited in the neighborhood of up to about 200 feet per minute on belt speeds. And to really lay material down on the belts and singulate so that you can separate becomes the key. I don't know that we overcome that by just simply speeding up belt. I think we're going to have limitations on robots for quite some time because they can only move at a certain speed. And even if you try to speed them up just from inertia alone, trying to hold on to materials becomes more difficult. So it's kind of a domino effect. That being said, though, the number of units that get put into place come into play. We can spread belts, we can make them wider belts, and then in the end, you can use them in series. Right now, you see most of the robots being put on the container side of the business. It's not to say that there haven't been installations and successful installations where they're on fiber lines, but where we started our whole conversation on the size of MRFs and the speed of MRFs and the regionalization, when you start trying to push 35, 40 tons per hour and trying to have robots as the sole answer, they're always going to work in conjunction with optical sorters. Optical sorters and robots work hand in hand from now into the future. And I believe that you'll be able to see tandem robots able to handle wider belts at a little bit higher speeds than they currently do now.
6 months, 1 year, 2 years, 5 years?
Again, it's beyond just testing. So if you were to talk about robots on fibers, for instance, it's beyond just testing in labs right now. There are manufacturers that have them out on fiber lines, and I would say that they're improving on a daily basis. To say perfection to the 97% efficiency, 95% purity, turn it around whichever way you may, but getting in the high 90s on efficiencies and purities at those higher speeds, you could do it today, but it's going to take multiple robots, and so you need to be thinking in terms of 2 or 3 robots on QC positions, and then does it pencil out?
I'd like to just add a little bit to that and agree with 100% with everything Chris just said about robots and where they're at. I do have 4 robots currently on fiber lines here in this plant behind me. And I think when you look at this from a fiber line perspective, or any place really, I look at it from a perspective of, what are my sorters doing? Are they averaging 40? Are they averaging 20 picks per minute? There's some marketplaces that are different than others. So if I can put a robot on a fiber line where my averages are 30 picks per minute, and by the way, that's not 30 picks per minute for an 8-hour shift, right? That's when somebody's looking. So we're seeing those picks per minute on the human side being, number one, if you can find the position, if you can find the person for the position, they're on the lower end of the picks per minute. So you put a robot in and you have it picking, it's not going to be 100% perfect, but it's going to actually get more picks than a lot of the human sorters in different marketplaces. Again, that's a whole another conversation. Some marketplaces are different than others. So just want to throw that in there.
Got it. So John Henry is going out, steam shovel's taking over.
Right.
Okay, so let's also talk about applications of traditional MRF equipment being used in other areas. So we've all seen reports recently that a significant amount of UBCs are lost in the fiber stream, and that perhaps adding an eddy current separator could pay for itself. There's also suggestions that it could be useful in the glass bunker as well. So thoughts on this, as well as any other unusual applications for traditional MRF equipment?
So, Ann, thanks for the question. I'm just going to circle around back to the robot optical sorter discussion. If we look back some 30 years ago when the first MRFs were being built, largely on the East Coast that served the entire country, and we look at where the equipment came from, it came out of the agricultural farming industry as well as the mining industry. The equipment from the ag industry maybe lasted 3 months, fell apart, and the mining industry lasted forever, super heavy duty, rugged, very expensive, very bulky. Over time, that equipment sort of all disappeared and equipment started to be made, conveyors started to be made, very specific to our industry. On the optical, the same thing happened. The opticals that enter our industry, the very first ones that we installed in the mid-90s, came out of the food industry. They were basically used to sort peanuts and sort olives, sort bad potato chips that have a black spot on it. They came out of the food industry. They were adapted to the recycling industry. The reason why optical is so successful today is because they are designed and installed specifically for our industry. And if you looked at the opticals of today and you look at what the ones that came in from the food industry, they're night and day in performance, size, every aspect of it, and particularly in Brent's comment about maintenance. For sure, the robots are the same story. The robots that you see today are going to all disappear in short order in terms of what they physically are mechanically, not the software part of it, but the actual hardware, the actual mechanisms that are doing the sortation are being adapted from other industries and being put into the MRF environment. As we learn more about how they perform, the machines will be custom designed, and as the demand on the market increases, the manufacturers will respond and they'll be able to make themselves the actual mechanisms tailored for the industry, and then we're really going to see a significant jump in movement and where they are and where they go. And we've seen that evolve also on screening equipment and baling equipment, the same situation.
Well, thanks for that. Now I'm going to re-ask the question that you pivoted or punted or ignored. So with respect to the UBCs, perhaps getting lost in other streams, do we expect any traditional equipment to be used other places in the MRF, or is that really not something we expect to see?
So on the eddy current separator, which is the predominant piece of machinery that's used to separate non-ferrous metal from everything else, and the predominant non-ferrous metal is the UBC. Many MRF operators overburden their eddy current separator, particularly when there's more smaller plastic and smaller paper. So we see a loss of aluminum throughout these systems because the units that are in there are too narrow, they're not large enough. In addition to that, the design of the rotors are not as effective as the rare earth magnets that are available today. And also operators adjust the splitters in their eddy current separator. So there's a fair amount of aluminum that's being lost as they are trying to recover and produce a UBC grade. And then, of course, there are other kind of alloys that are not UBC that, kind of twist up this whole thing. At the end of the day, the optical sorters can be provided with a component, a metal detection component. It can also remove, detect, and eject. Adding the ability to recover more aluminum by adding another eddy current separator certainly is a way to do it. Another way would be by going after using the optical sorter equipment that you may have to be able to do that. And the other is to adjust the splitter and adding a quality control station there to get up to a UBC grade. But ultimately, if we go back to the beginning of the lines where the screens are, a lot of material is being lost through the screening technology, and we're all seeing screens getting cut up, scrapped, and replaced with other types of technology. So there are other things that are going on that will improve UBC recovery.
Yeah, I'm in agreement with you on that completely, Nat. It's first you got to source where you lose it, right? And you've hit the three areas where you could lose it. A flattened aluminum can across a standard fiber screen, it's light in weight. It's easy to transfer into the fiber stream, and a lot more these days. You're seeing optical sorters on that fiber stream that are doing a job of removing contaminants and sending what we're calling contaminants in the fiber stream back to where they need to be to recover, which is the container stream. So you'll have some flattened PET that'll go with it. You'll have some aluminum that'll go with it. And now you've got a chance to recover it on its existing container line, where historically you've seen a lot of aluminum, the pucking effect, and smaller aluminum getting lost that may have not been recovered was like you had asked about the glass or the fines line. And technologies that allow a 2-inch gap to turn into a 3 and a 4-inch gap over time just due to wear are going to lose those. So, if that technology is in the MRF and the MRF isn't necessarily going to spend the money to change from a wearing type mechanism to one that will maintain its same spacing, then it makes sense to consider, because the loss of UBCs to a fines line can be quite significant.
Yeah, I couldn't agree more with that. I guess the one thing I would say is operators, right, like Chris had said and Nat, really understand where that material is ending up. So do those audits of your fines, do the audit of your residue, and, see what's in there. And then that'll help you, kind of process of elimination, go back to where it's coming from. We are seeing some of the UBCs end up in some of our glass. So that's an area that we've focused on in a few of our plants right now to try to correct that. And that may be putting in, discs that have worn, like Chris said, or it may be putting in the eddy current on the glass stream. And we're looking at both options, and like I said, in a couple of different facilities right now.
So before we get away from technologies used in the MRFs, let's talk about fire. Like, we're hearing more and more about fires occurring on a pretty routine basis now in MRFs. What technologies are out there? What can be done to try and mitigate the fires, or is this not a technology solution? Is this more, just employment or a labor solution? What's the solution? Is there a solution?
Well, to start, you hate to hear it this way, but education first. That's the start of the solution. And I think NWRA and a lot of people have done a great job of sending the message out there. But the interesting thing is, I actually saw somebody commenting on LinkedIn not too long ago that had made a comment about, batteries, and it was talking about how batteries aren't part of the recycling. But the more we say battery and the more we say recycling, what's actually going into that person's head. We hope that they're not hearing put it in the container, but it's the general consumer. From a technology aspect, though, I understand that there's dumpsters that are being outfitted with technologies to find contamination. I understand that same technology is possibly going to move into the trucks and the collection side. But the second that it's tipped onto the MRF floor, we'll call lithium-ion batteries the culprit. I mean, they can be of so many various sizes, shapes, and materials. It's really hard at the technology side to stop it, because it can just as easily be in the tip floor as it could be in the bale. I think most of what we see begins on the tip.
Well, let's move on to material. So we've already mentioned the evolving ton. Obviously, we're all familiar with that decline of newspaper, rise of OCC. MRFs have to be designed based on the waste recyclables composition for a period of 5, 10, even 15 years. So now that we know that things are going to continue to evolve, what is being done to be able to say, be flexible so that things aren't designed for 15 years and they're not stagnant, and that there is a recognition that the material mix is going to change?
So it's an interesting question, and the dynamics are quite different between the municipal sector and the private sector. So I want to come back to that comment. The municipal sector finances, pays, owns, and operates many facilities throughout the United States, as does the private sector. So on the subject of the evolving ton, the equipment life and decision-making process is like completely different from those two different situations. Our experience in the municipal sector and how they go about doing their purchasing, it's a long process, very thoughtful process with procurements, big specifications, typically looking for useful life of 25, 35 years. It's actually stated in their documents. They don't really think too much about obsolescence. They're thinking about just the long hurdle to get the approvals and get it done and get it implemented, and looking for a very robust plan. Private sector today, more than likely, are asking questions like, why would I want something for 25 years, the last 25 years, when in 5 years I'm probably going to replace it? And the method of replacement is going to be pretty quick and nimble on the private side. So when we look at the evolving ton and what's happening, that's part of the equation. I mean, why or how can you justify a piece of equipment and make a position that's going to take a 10-year return on that investment, and it's going to last 20 years, like you might for other things in construction or capital projects, when historically we've seen in 2, 3, 4 years, the incoming stream changed dramatically, and on the outside, our customer is changing what their specifications are. So when we're looking at equipment selections and the equipment life and the useful life, we typically would see that private owners, private operators, companies like Brent's company, a lot of the customers that you have, Chris, and a lot of our customers look at things with a open mind towards, I'm going to put this piece of equipment in, but if I'm not happy with it, it's going to come right out.
Sticking with these materials, how many commodities does the average MRF make now? Obviously, it'll vary with markets, but are we at the maximum number of different material streams that we can make, or are there things that we can add? And did you want to follow up on what Chris said?
No, I'll answer the question and just tie in a little bit of that previous question too. But so yeah, I mean, I think traditionally MRFs have been designed to handle, around 10 different materials, I'll say. But that initial design, I mean, obviously that has a huge part to play in what you can do in the future. Not everybody has the availability of space, but we try to, like in any new design that I'm looking at, we're trying to add space so you have some flexibility. You give the manufacturers, their engineers some space to work with. That seems to have helped in a lot of different areas. As far as the stream goes, I do think technology is going to help us quite a bit, right? You're going to see more artificial intelligence up front at the beginning of a stream. You have a separation issue, but we'll get there as far as separating the material so the artificial intelligence can read what exactly is in that stream. And then that helps you make decisions on how many commodities you want to sort and what kind of space you need. And then obviously what comes into play too is there a home for the commodity? Is there a long-term home for it on the back end? Otherwise, it wouldn't make sense to recycle it if you didn't have that back end home for it. So there's a lot of factors that come into play on that one.
Okay, so with that, what's next? Is there any new commodities, Chris? Do you see any subsets or new things that we think are going to be made and sold in the future?
Yeah, so obviously new is relative, but the polypropylene has got certainly a significant place in the marketplace, making that its own commodity. Many MRFs are already doing that. It historically went in the 3 through 7 mix and still was recovered by the polypropylene processors. So although relatively new, there's a lot of grants and funding available to those out there that are looking to institute polyprop. We touched on it earlier, flexible packaging, recovering that out of the stream. I personally have a hard time thinking that that's going to be a long-term play. Just because the various materials that are made in flexible packaging, the multi-layer films, anything from a polyethylene low density to high density to a polypropylene to nylons as a center fill, it's going to be a hard to recycle material. But Brent alluded to it. If brand owners can help find those recycling markets, then the technology, those could be another subset of the existing material stream that we could pull out.
So that's great. What about the opposite side? Nat, I'll ask this of you. Any current commodities that we expect that are going to go away? Obviously newspapers, I don't know, anything else.
Yeah, newspapers is hard pressed. I don't even know if you're allowed to come out of your house to even go out and buy a newspaper. So, let alone somebody delivers to your house, you're not even allowed to touch that newspaper. But no, seriously, the sorted residential paper or the newspaper is a diminishing grade for sure. So we're really looking at a mixed paper grade, and most MRFs were designed to produce maybe 2 or 3 different types of grades of fiber other than OCC. And today, logically, many MRFs just make a mixed paper grade and that's it. And including the flexibility in the future to be able to go back seems, in most cases, not the direction that most MRF operators are interested in. There's no going back because newspapers aren't going to be flooding us again as they were in the 90s or the 2000s. Other commodities that are going away, in a sense, is film as a product to be made. I think film is still in the stream, so it's not going away. In some cases, it's been banned, like again, I'll mention New York, other states as well, but it's still present, but as a commodity versus trash. So people made a lot of efforts to separate film and try to make products into the marketplace, difficulty making market. Others are letting it go straight as trash or as residue. So we see that particular commodity fluctuating back and forth very quickly. Glass. So in different parts of the country, like in Utah, I'll use as an example, glass is not part of their program at all. They don't. Glass is not recycled through our MRF program. In fact, in Europe, in many countries, glass is not recycled through their MRF structure either. Glass is separate. It's collected separately. So glass has the potential of, quote, going away and being addressed in a different method of collection and so on. And in terms of Chris's comment about how some new commodities coming along, which relates to some existing commodities that may go away, and that is the bundling of plastics all into one grade, a 1 through 7, just let it go. So rather than trying to segregate and make a PET bale or an HDPE bale and dealing with all the injection molded versus the blow molded versus, the blue, the yellow, the green, the clear, all the different colors, there's definitely a movement towards making a bundle of just a 1 through 7 bale. I'm going to make it a clean bale. It won't have anything else in it, like glass or paper or metal. But it's going to be a product that for some people might consider that to be a new product. Thanks, Nan.
I was actually curious, just maybe to add something. When we talk in the world of the 1 through 7 bale, or a lot of them are already with separating 1s and 2s, and now we start talking about the 5s and what could go away. What becomes of that? What are y'all forecasting, Brent, on a 3 through 7 bale and facilities where you're going to pull out the polypropylene? What's left?
Yeah, I mean, that's a fantastic question. We seem to adjust as processors to what the markets are doing at any given time. And if you don't, obviously there's other issues. But, on that blend that's left at the end, I think there's some creativity out there in the marketplace that's looking at that mix and coming up with solutions for the industry. I think there's some stuff on the fringes on that right now, but I think that's coming. Again, we're adjusting as processors, but the back end is adjusting as well. We talk so much about, diverting waste on the front end. That back end has to be that's a whole nother conversation, right? The end users and capacities for different materials in the country. We're diverting as much as we can. And that back end, I mean, there's been some investments in that market that are helping the industry as a whole in the U.S. right now, or North America. But I think there needs to be more investment on that front. And I think it's coming, but slowly as we've seen as processors.
Sorry to steal your questioning, Nan.
No worries. So I heard Brent mention fringe material. So let's do a rapid fire round on a few materials and see what you guys think. You don't all have to be on the same page, but about the following materials and whether they're recyclable now, has a time horizon of a couple of years, maybe 5 years, or perhaps never. So I'd love to hear your thoughts on these. So I don't know if you guys have seen this, but Tom's of Maine has a HDPE toothpaste tube, and it says right on the toothpaste tube, recycle it. So what is that? Now, 1 to 2 years, 5 years, never, longer.
Starts with an N, and it's not now.
My answer is if it's less than 2 inches in size, it will end up in the trash.
Yeah.
Agreed. It's great, right, that we have that problem in the industry. It's been it says it's recyclable on the material, so it must go in the recycling bin, right? So great that they're doing that, right? They're making a material that is recyclable, but I would say the systems today aren't ready for something like that. So
obviously expanded polystyrene, or some people say styrofoam. A lot of people have paid a lot of attention to that. What do we think of that?
Brent, you need to take that, man. I remember your little baler over at Alpine.
Yeah, well, I mean, I do dabble in that. So, obviously you have a couple of issues. Is it going to break up? Is it going to make a mess? The answer is it'll break up a little bit. I haven't seen it make a mess in my system in Denver, where we do try to pull it out. Then obviously you have to densify it, and it has to be clean, right? They don't want any dirty polystyrene products, and that is an issue as well. So you have to be very selective if you're going to take it. There is a good market for it. It's got decent value, but that also comes back to a hauler may not want to add it because it's going to take up space as well, right? making a few more hauls. It's such a small percentage of the stream though too. So while I do it in one site, I don't do it in all of my sites. It works for me in Denver, but it may not work for me in another site.
So I'm going to respond, and maybe not in the popular way, but as a MRF processor, I would say if you want to pay me more money to process this material, which weighs very little and is very challenging in my facility, I suppose I might consider it. So this sort of falls into the category and of never, meaning that there's been money put at it, there's been efforts put at it, but as in terms of it being a mainstream commodity that we will see in the MRFs, I think the answer to that is never. I think it will be a boutique commodity where people are willing to pay for it and there's an opportunity for it. We will continue to see it from here to there, but it won't be a mainstream product.
Coffee pods, these are the things that you make one cup from, you put in the machine.
I'll just start off by saying the manufacturers, I think, have done this is a case where they've done a good job of switching to materials that are recyclable in polypropylene in most cases, I believe. So yeah, I'd say it's a now for me. I have a robot actually pulling those in Denver at the moment, so I just add them with my other polypropylenes, and the end user has agreed to take them, and it's not an issue. But yeah, so coffee pods for me are good.
Okay. Anybody else want to touch coffee pods?
I'd just elaborate on what Brent said. The producers have done an excellent job of doing everything they can to make them available. Lots of testing has been done, both from robotics and optics, but also where is it in the MRF? Kind of goes back to Nat's comment on the toothpaste tube. If it's less than 2 inch, if it's crushed, if it's falling through. So, but numbers have shown that you can find a good amount of these cups on your container line. So I can't put it as a now, but I can see because of the producer's push, 5 years.
So there are some challenges because those cups have the residue of the material that was in the cup. So we're introducing organics into the facility, and that creates odors and other issues. So I don't think the industry has fully understood what those issues are. The other thing about the cups is there are certain manufacturers that make their cups and use aluminum in their product, like an espresso machine. So obviously the value of the aluminum is quite different than in the plastic. So I think this is an evolving item. So I'd put it more in the 5-year kind of bracket. I mean, there's definitely opportunity today, again, but in terms of being a mainstream item in this as a standard item, like the way a milk jug is, I think it's a 5-year or maybe a little bit more than that, that we would be seeing these items. And most MRFs would have to do some significant modifications to get that out of their fines, out of their glass breaker stream or their fines.
Okay. So one last rapid fire, pouches.
I'd say it's flexible food packaging, cheese type, Ziploc, multi-material, never.
Granola, yeah, pouches.
Hope the Flexible Packaging Institute can wind up finding markets for it. I question it. So I've got it as a never, but I'll cheer them on.
Oh boy! So you're getting the phone call now.
I know I am.
I'll get it from the styrofoam folks.
I'll agree with Chris on that. It's a tough one to handle in a MRF environment. Cleanliness is a huge issue with end users on that stuff too. And there is some wrapping that happens with that material, so it's a tough one. I don't see being able to handle it anytime soon.
Probably not a popular answer, Ann.
Okay, so Nat, I'll spare you the grief because we don't want you to get too many calls after this. Let's do one last question and then we'll wrap it up. I'm getting the signal that we're running out of time. So I'd like to touch briefly on contracts. So we've heard a lot about MRF contracts, and so when you're designing or building a MRF, is this something, chicken or the egg? Do you build it and they will come, like Field of Dreams, or do you have to have contracts in place? Do you have to have guaranteed material before you start looking at building a MRF somewhere?
I'd say that traditionally there's been a couple pieces to that puzzle on building a MRF. Is there enough volume to support it? I think that's probably something that will always be in the mix on that decision. With that in mind, I'd say, yeah, you probably have to have some sort of anchor volume as a priority when you're doing something like that. Obviously, competition in the area. Will the marketplace support a MRF or another MRF in some cases? Competition is a huge factor when building a site. Commodity values, that's the older way of thinking as far as you can count on values being there. You cannot count on those values being there today. Will the marketplace support if you go to a charge scenario like we're in today? Which then landfill prices come into some of those discussions as well. So yeah, there's a bunch of different pieces to that question, and then of course how efficient a MRF can be. Can you run it with 10 sorters at 25 tons an hour or whatever? That's a huge piece. Can you get pretty efficient with sorting if you're going to build a new MRF, and do you have the funds to go that route with the opticals and artificial intelligence and robots and so forth? So there's my
Real
take
quick on that, and just from what I've seen on the manufacturing side is that, you roll the clock back 6, 7, 8, 9 years ago, and the Field of Dreams purchaser did come along. If I build it, they will come. And that's gone away. We really aren't seeing people building on just vision. That the contracts need to be fairly secure.
And I would add that, Chris, you don't build machinery without a purchase order. So it's similar kind of concept. And also one of the benefits of a contract is what you built, what the MRF is going to be doing in terms of capacity, types of materials that you're going to be processing, arrival times. Is it coming in transfer trailers? Is it coming in side loaders? And then ultimately, without a contract, one of the things that we've heard for the last 2 or 3 years is contamination. And one of the methods to manage contamination is through education on the collection side. And if you're not connected to a contract, and you don't have any idea of how you're going to manage the contamination side, you'd be building a MRF without any idea of, are we going to get 5% contamination, 10, 20, 15, et cetera? Am I going to have glass? I'm not going to have glass as part of the stream. Is it going to be dual stream? Is it going to be single stream? Too many questions to be able to be answered without having some sort of assurance. On the other hand, we have seen some facilities built by owner-operators that have other businesses as a strategy to win a contract, meaning they have an eye on a contract that's coming out in the next 2 years or 3 years. They want to get a jump start, get the MRF built, and one of the conditions of the contract is they need to have a facility in place. So they build a facility, and now they're well positioned to compete in that contract, and they know all the other facilities that are in the marketplace, and from a capital cost and operating cost, they can be very competitive. So it's a calculated risk on their part. You can count those on your hand, though.
Got it. Well, this has been an excellent discussion, and we're at time. I know we could have gone on for a lot longer. There are several questions I meant to ask that I didn't get a chance to, but I think that just shows you how great this discussion was. So thank you, Brent, Nat, and Chris, for sharing your knowledge with us about MRFs. Stay well and enjoy the rest of your day. Thanks.
Thank you, Ann.
Bye. Thank you, Ann. Thanks, guys.
Bye.
Bye now.